Okay, your bell ringers are on the board. Please take a few minutes to go through these. So the first one, we're doing the equation for a line. So if you think of what we need for a line, we need a slope and we need a y-intercept. Okay, so remember slope formula, y2 minus y1 over x2 minus x1. We can use that because we have 2 points. So it's 11 minus 4 over 8 minus a negative 2. So that gives us 11 minus 4, that's going to be a 7. And since that's a double negative, it turns to a plus, so it's 10. So we can either use y equals mx plus b, which is slope-intercept, or we can use point-slope. I think point-slope is easier. We got a point, and we got a slope, so we plug them in. Y minus 4 equals 7/10 x plus 2. That's your equation. Okay, if you remember one of these exponential equations, we need to have 2 points, we need to make an exponential equation. So remember, exponential equations are these, a times b to the x. Okay, and remember we're either going to have to, divide these to get rid of the a to get a b. So we got to plug in our points. Okay, so we have our first equation, y is 10, a times b squared, and then our second equation, y is 50, a times b to the 4th. Okay, and remember, I would probably do the bigger power, that one, divided by the smaller power, that one. Okay, so if I were to do these, let's see if my smartboard lets me, nope, it's together. So I would do this one here and divide it by the smaller one. So 10 equals a times b squared. Forget about that one up there. So that's the way we're dividing it. So that way we have positive exponents. So 50 divided by 10, that gives me a 5 equals, the a's cancel. And then we have b to the 4th over b squared, so that gives me b squared. So to get b by itself, you square root both sides. B is square root of 5. Okay, and you can change that to a decimal if you wanted to. And now we're going to take that square root of 5, and I would say we're going to plug it into that equation, and we're going to get the a back out. So 10 equals a times square root of 5 squared. That turns into a 5. So now we have 10 is equal to 5a, so a is equal to 2. Now we just need to write that and that back in our equation. So it's y equals 2 times square root of 5 to the x. So that's our particular equation that we're looking for. Okay? So next on here I have a few problems I want you guys to review for solving logs. So go ahead and pause the video and people can try to finish these 2 problems. Alright, on the first one, we did one exactly like this yesterday. I think we might have done that exact problem, but we can combine these 2 logarithms by multiplication. So to do that, we have the natural log, x plus 2 times x minus 2 equals 0. So this is a pattern that turns into x squared minus 4 equals 0. So remember what that special word I said yesterday was when we had to fix stuff like this? It was exponentiate. Or really, in short terms, change it to an exponential. So it would be e to both sides. So you have e to the 0 equals x squared minus 4. That turns into a 1. So you subtract 1 from both sides. And you get, oops, take that back. We want to keep the 1 where it's at. So we're going to add 4. That way we get x squared by itself. So that's going to be x squared equals 5. X equals plus or minus square root of 5. Ugly 5. Okay, that's that one. Now, we did not do one like number 2 yesterday, but we should be able to. There might have been one like that on your homework. Okay, so you got to think of all the rules of logarithms that we have. Well, we have a 2 out in front there and a 3 out in front there of those logarithms. Remember, one of our properties was anytime you had a number out in front of a logarithm, that could go up top as an exponent. So really, if we rewrote this, log base 3 minus log base 3, so it'd be 2 squared, which is 4, and then the other one over here would be log base 3 of 3 cubed, which is 27. Oops, I lost my x. So on the left, so now you can't do anything yet until you combine them in single logs on both sides. So really, this one on the left, okay, that stuff, if you subtract logs, remember you divide. So this turns into log base 3 of x over 4. So you just read it from left to right. Log base 3 of 27. So now we got our rule, so we get rid of our logs. We have x over 4 equals 27. So we got x equals 27 times 4, which is 101. 4 times 20 would be an 80, and 4 times 7 is 21, so 80 plus 21 is 101. That is your answer. All right? So that was our review from the stuff from yesterday, and now we're doing actual logarithmic functions. So yesterday I told you guys that we were going to be looking at graphs, so we're going to be looking at more like patterns than actual graphs. All right, so go ahead and write this down. Write the title down. All right, so looking at what we're starting with, so kind of review. You don't need to write everything down here. So name the type of function that goes with the following properties. So add. Remember that was linear. And then we had add multiply. Which one was that? Well, that one was a power function, or exponential functions. Okay, now the next one, the multiply, that's your power function. And now looking at logarithmic functions, if we try to put those in conjunction with one we've done before, well, we said exponentials and logarithms were inverses. So if we look at these two connected there, what's the inverse of an add-multiply pattern? Well, it's going to be switching them around. So it's multiply, add. So you're multiplying the numbers on the left of the pattern, and you're adding the numbers on the right of the pattern. Okay, we're going to use that here pretty soon, like the next slide. Okay, so looking at that one, pause the video, write this down, so that way you guys have something to reference. So what's the pattern we notice? Well, seeming that we're working on a function of logarithms, it's probably going to follow the logarithmic pattern, okay, which means we're going to multiply on the left and add on the right. So if we look at the numbers on the left, so we're assuming that we're multiplying, so this would be times 2. So does our pattern follow? Yep, times 2 again. Times 2 again. So then that means we're going to be adding on the right. So what number are we adding? Adding a 4. Are we adding a 4 on the next one? Yes. Are we adding a 4 on the next one? Yes. So this is indeed a logarithmic function. Okay, they're going to be like that. You're going to check for patterns like that. You might need to use it. Okay, you might need to use patterns like that to figure out numbers that are farther down the XY chart. All right, so you don't need to draw these down. You can sketch them if you want to, but it's not 100% necessary. Okay, so looking at this note here, it says logarithmic functions are inverses of their same base to exponential functions. So if we're looking at the first function here on the left, so this graph here, kind of tracing it with my green marker, okay, that's y equals e to the x. That's the exponential function with the base e. So if we follow this inverse of their same base exponential functions, that means the inverse would be this one here, which is the natural log of x. Okay, those two are inverses because if you think of the base e, that would be your exponential that you're using. Okay, so if you have 2 to the x, like the one on the right here, the inverse graph is going to be log base 2 to the x. That's kind of something cool to see there. And if you remember, what's the equation of this line here? Okay, think about it for a minute. What do both functions equal when you plug them into each other? If they're inverses, they're supposed to equal what? X. So the equation of this line is y equals x that they're reflected across. So same thing applies here. I'm reflecting over that line, y equals x. So you can take the top graph here, and you could fold it in half over that line, and it would line up with the green. Okay? I want you guys to write this down. This is what we're going to be using for general logarithmic functions. So go ahead and pause the video so that you can write it down. So we're going to be using this to determine actual functions that we need to use. So we have y equals a plus b log base c of x. Okay, and generally c is going to be a general, like it'll be log base 10, it'll be a common log. That's what we're going to be using unless it's stated otherwise. Okay, but we're going to be doing it kind of the same way as we found exponential functions and power functions before. So that's your general form. I want you guys to remember that. You're going to need it. So the first problem, go ahead and write down the important information for the problem. So go ahead and pause the video so they can do that. So we're looking at this example. Suppose that f is a logarithmic function with values f of 3 equals 7 and f of 6 equals 10. So without finding the particular equation, find f of 12 and f of 24. So remember how we did this stuff before. We had to make an XY chart with those values. Okay, so we're going to do A kind of down here. You had to make an XY chart with the given values. So X is a 3, Y is a 7, X is a 6, Y is a 10. What was the pattern of logarithmic functions? Well, we know that it's inverses of exponentials. So exponentials were add, multiply, so we got to switch that around. So it's going to be multiply, add. So what are you multiplying by on the left? To get to from a 3 to a 6, you'd be multiplying by 2. So we know that the next number in line over here is going to be a 12 if we multiply by 2. On the right, we're adding 3. So we know that the next number in line is going to be a 13. So we know f of 12 equals 13. That's one of them. If we keep going, we need f of 24. So that means we're going to have to times 2 again. We'd have a 24. And then we're going to have to add 3 again. We get a 16. So f of 24 equals 16. Those are the two numbers we're looking for. Okay, so now for b. Okay, b is where it gets a little bit tougher. It says find the particular equation algebraically using natural logarithms. So just like when we found power functions before, we're going to have to plug them into our general form. So our general form equation was this. All right, and we're just going to assume that we have a base 10. So plugging in our points, we have x, y, x, y. Those are the two equations we're going to make. So we have 7 equals a plus b log 3. And we got to make another equation. So we have 10 equals a plus b log of 6. So now it's not as easy as just dividing them. I'd say it's even easier with this one. Because we have to get rid of the a. And in order to get rid of the a, we can just subtract the two equations. So if I look at those two and I subtract them, I'm going to take the smaller one from the bigger one. So that means I'm going to change these to negatives. Okay, those are the ones I'm going to be subtracting. So in order to get logarithm equations, we need to subtract the two equations. All right, so if we subtract those two, we got 10 minus 7, which gives us a 3. A's are going to cancel because you got a and a negative a. But now we're going to have b log 6 minus b log 3. Okay, now your brain might be saying, well, we can combine those logarithms. Not really, because we got the b out front. We got to figure out how to get the b out of both of those because that's what we're solving for. So when you have a variable that's in two separate pieces, how do you get it out as one? You're going to have to factor. So that looks like this. I take these b's and I factor it out of both of those. So it'll be b log 6 minus log 3 because I took the b from both of those. I still have the 3 over there. So now what do I got to do to solve for b? Well, I have this group of stuff on the right here. I can just divide that out. And that's really a number. If you were to put those in your calculator and log 6 minus log 3, you can use the decimal. Okay, I'm going to do that here in a minute. So we have for b, we have 3 over log 6 minus log 3. And that actually gives us that b is about 4.328. And about 4.328. That's what b is. So now what do you think we do to find a? Yes, we're going to use b and plug it into our equation. Okay, so if I did that, I'm going to use the first one because it's got smaller numbers. So, plugging it in to here, I have 7 equals a plus, we now have 4.328 log of 3. So then that means this number right there, that 4.328 log 3, you would subtract that from both sides. And sorry I'm not punching all this in my calculator. I don't have it on me at the moment. Okay, that's going to cancel on the right. Then we have a equals 7 minus 4.328. We get a is about 2.245. Then we just piece our equation back together with those. We have y equals 2.245 plus 4.328 log x. And that's your equation. Oh, and I think we wanted to use natural logs. Right, I missed, that's okay. Rather than having logs here, we would have ln, the natural log. Okay, it's the same thing. We would just say that natural logs is base e. I assume we wanted to use base 10, so that's why I used logs, but here we'd have to use natural logs. So just change that to natural log x. It'll be the same thing. Okay, and then for c, it says confirm your equation gives you the value of f of 24 you found in part A. Well, what does this mean right here? That means plug in 24x or 24 4x and see what you get. Okay, go ahead and plug that in and see if we get the same answer. If you didn't get the exact same answer, then it should be pretty close. You might be off by a few decimal places, but that's just because we rounded here and there. Okay, but it should be pretty close. Okay, go ahead and write that down. Wait, we just did that one, so we're good here. Okay? So that is everything that we should have had to cover, because this is really that example broken up into different slides. Okay, if you need the sub to go back, they can rewind that. Okay, I'm going to send you guys the video link in an email, but that is the gist of the lesson. Okay, so for your homework, you have a worksheet on logarithms. The first part of it is a worksheet just doing practice problems with logarithms, and then there's a second page that just says to do book problems on there. So do the book problems on that page provided. Okay, if you got any questions, you guys can send me an email, but that should be everything.